You think falling into a black hole is about violence. You picture screaming atoms, stretched bodies, instant annihilation at some cosmic cliff edge. That picture didn't come from physics. It came from movies that needed drama to happen on cue. Well, that's your first mistake. Because the most terrifying truth about falling into a black hole isn't what happens at the edge. It's how little happens. You were told the event horizon is a death line. Cross it and boom, reality snaps, you're torn apart. Credits roll. No, that's not how the universe works. An event horizon is not a surface. It's not a wall. It's not a glowing ring of doom waiting to vaporize you. It's a boundary defined by light, and light doesn't care about your fear. From your perspective, your clocks, your atoms, your sense of time, crossing the event horizon is unremarkable. No shockwave, no sudden force, no cosmic alarm bell. You don't feel gravity suddenly spike. You don't feel yourself freeze. You just keep falling. That alone should unsettle you, because everything you've been taught says something dramatic must happen there. It doesn't. The reason is simple and deeply uncomfortable. The laws of physics don't change just because you crossed a line defined by someone else watching from far away. The event horizon only matters to observers who aren't you. And already, your intuition is in trouble. Here's the misconception hiding underneath all the sci-fi noise. You assume gravity near a black hole behaves like gravity on Earth, just stronger, pulling harder, crushing more. That sounds right. It isn't. Gravity isn't a force in the way your muscles understand force. It's geometry. Space-time tells matter how to move, and matter tells space-time how to curve. When you fall, you're not being yanked downward. You're following the straightest possible path for warped space-time, which means, this part really annoys common sense, in free fall, you feel nothing. Astronauts orbiting Earth feel weightless for the same reason. They're falling too. A black hole doesn't change that principle. It just pushes it to an extreme your brain never evolved to handle. So, when you cross the event horizon of a sufficiently large black hole, your body doesn't register some sudden catastrophe. No alarms in your nerves. No pain signals screaming you've crossed the line, because locally, nothing special happened. And that's the trap. Meanwhile, someone watching you from far away sees something very different. They see you slow down. Your clock ticks more and more slowly. Your light redshifts, fades, stretches. To them, you never quite cross the horizon. You freeze, you dim, you vanish. Not because you died there, but because information from you can no longer reach them. Both perspectives are correct. Let that sit for a moment. You cross the horizon. They never see you do it. Reality is not agreeing on what happened. This isn't philosophy. This is measurement. Time itself refuses to behave universally. And if that doesn't bother you yet, you're not paying attention. Because now we get to the myth everyone loves, spaghettification. You imagine being stretched head to toe, ripped apart atom by atom, long before anything subtle happens. Sometimes that's true. Sometimes it isn't. And the difference has nothing to do with mercy or intention. It's size. Small black holes have brutal tidal forces near the horizon. Your feet fall faster than your head. Your body can't hold together. End of story. But supermassive black holes, the ones sitting at the centers of galaxies, play by different rules. Their horizons are enormous. So enormous that the tidal forces of the horizon can be survivable. You could cross it intact, still alive, still conscious, still thinking you haven't reached the bad part yet. That's the terrifying correction. The universe doesn't guarantee a dramatic ending when intuition expects one. It lets you pass the point of no return without telling you. And that raises a much deeper problem, because if the horizon isn't where things end, where do they end? Inside the black hole, all paths lead inward. Not because you're being pulled, but because space-time itself tilts that way. Forward in time becomes inward. You can no more avoid the center than you can stop tomorrow from arriving. And here's where physics starts to hesitate. Equations still work up to a point. Predictions still hold up to a point. But eventually, the math points to something it cannot describe. A singularity. Not a place. A failure. A breakdown where density becomes infinite and our understanding collapses. That's not a monster waiting for you. That's a warning sign for us. It says, beyond this, our models stop surviving reality. And notice what's missing from that statement. There's no guarantee of destruction, no cinematic explosion, no cosmic justice, just ignorance. The most advanced measurements humanity can make tell us exactly where knowledge ends. And black holes don't hide that fact. They advertise it. You think falling into a black hole is terrifying because of how violently it kills you? That's a comforting belief, because it keeps the universe emotionally legible. The real terror is quieter. It's that the universe allows you to cross the most important boundary in space-time, without sensation, without warning, and without consensus on what even happened. And this is only the beginning, because we haven't even talked about what happens to information. We haven't talked about whether the universe forgets you. We haven't talked about why the most precise theories we have violently disagree, right where you're falling. That's coming. By now, you're probably trying to regain control. You're telling yourself, fine, maybe the horizon isn't dramatic, but surely the universe settles things quickly after that. Surely there's a clean ending. That's your next false assumption. Because black holes don't just break your intuition about danger, they break your intuition about time. And this is only the beginning, because we haven't even talked about what happens to information. We haven't talked about whether the universe forgets you. We haven't talked about why the most precise theories we have violently disagree, right where you're falling. That's coming. By now, you're probably trying to regain control. You're telling yourself, fine, maybe the horizon isn't dramatic, but surely the universe settles things quickly after that. Surely there's a clean ending. That's your next false assumption. Because black holes don't just break your intuition about danger, they break your intuition about time. Each second of your life takes longer to arrive. Signals you send slow, weaken, redden. You are not slowing down. Time is bending between you and them. That distinction matters, because slowing down implies a reference. Bending time destroys the idea of a single reference altogether. Now, scale that idea up. You're not just falling through space. You're falling through different versions of now. And this is where intuition quietly collapses. On Earth, cause and effect feel absolute. Event A happens, then event B. Near a black hole, even that ordering becomes negotiable. From your perspective, you cross the horizon before anything catastrophic happens. From theirs, you never cross at all. Ask yourself a dangerous question. If two observers cannot agree on whether an event occurred, what does occurred even mean? Physics doesn't dodge that question. It stares directly at it and keeps measuring anyway. And measurements say this: there is no universal clock. Now zoom out. Forget your body for a moment. Forget fear. Imagine the black hole itself over cosmic time. You were told black holes last forever, eternal prisons, cosmic garbage disposals. That's another lie, this one killed by equations. Black holes evaporate. Not quickly, not dramatically, but relentlessly. Quantum effects near the horizon allow energy to leak away, over time scales longer than civilizations, stars, or galaxies. Given enough time, the black hole shrinks, which leads to a deeply uncomfortable implication. If black holes evaporate and you fell in, where did you go? You can't answer that with imagination, only with consistency, and consistency is exactly what physics loses here. Because now two pillars collide. General relativity says information that crosses the horizon is gone to the outside universe forever. Quantum mechanics says information cannot be destroyed, ever, not usually, not unless gravity is involved, ever. Both theories work. Both are experimentally undefeated, and inside a black hole, they contradict each other openly. This is not a philosophical debate. It's an operational crisis. If information is destroyed, quantum theory breaks. If it isn't, relativity's picture of horizons breaks. Something has to give. And you are falling straight into the argument. You assume the universe is obligated to make sense to you. It isn't. Physics doesn't promise clarity. It promises accuracy, until it can't. And black holes mark the edge of that promise. Now consider scale again. Your fall feels local, personal. But the rules breaking here affect the entire cosmos, every star orbiting a galactic center, every gravitational wave detected from a merger, every precise GPS correction that already relies on relativistic time distortion. This isn't exotic trivia. Your phone works because engineers accept that intuition fails in curved spacetime. Black holes just refuse to let that failure stay hidden. They force contradictions into the open. And here's the deeper discomfort. You don't get to witness the resolution. From the outside, you fade. From the inside, physics marches forward until the math gives up. There is no experiment you can run past the horizon that sends results back. The universe draws a line through spacetime and says, knowledge stops communicating here. Not because it wants mystery, because causality itself breaks contact. So, when people say black holes are unknown, they usually mean we haven't figured them out yet. That's naive. Some unknowns are permanent, not due to ignorance, but due to structure. You cannot learn what cannot report back. And that should unsettle you more than any spaghettification fantasy ever could. Because now the fear isn't about pain. It's about falling into a region where reality continues, but stops being shareable. And we're still not at the deepest problem. Because we haven't talked about what happens when spacetime itself becomes unstable. We haven't talked about horizons fluctuating, or interiors that may not exist the way equations suggest. We haven't talked about what inside even means when geometry breaks. That's next. By now you should feel the ground giving way. Good. Because the next mistake people make is assuming that, whatever else happens, spacetime itself remains a reliable stage, that it bends, that it stretches, but that it remains a thing. That assumption dies inside a black hole. You imagine an interior like a place, some warped cavern leading down to a central point. That picture survives exactly 0 serious equations. Inside the horizon, inside stops behaving like a location. It becomes a direction in time. Not metaphorically, literally. Every possible future you have points inward. You cannot turn around any more than you can turn toward yesterday. This is not because you're trapped. It's because space-time has rearranged what forward means. That should already make you uneasy, because now we're not talking about danger. We're talking about inevitability built into geometry. And then things get worse. General relativity predicts a singularity, a region where curvature becomes infinite. Infinite density, infinite curvature, infinite breakdown. That word infinite is doing a lot of work. In physics, infinity isn't a destination. It's a red flag. It means the theory has been pushed past its jurisdiction. The equations don't explode because the universe does. They explode because the map stops matching the territory. So what's actually there? We don't know. And that ignorance isn't casual, it's foundational. Every attempt to combine gravity with quantum mechanics produces something radically different from your expectations. Some models replace the singularity with a bounce. Some smear it into a fuzz of probability. Some erase the interior entirely. Yes, entirely. There are serious proposals where the inside of a black hole doesn't exist in the way your language assumes, where everything you thought was volume is encoded on the horizon itself, not metaphor, accounting, reality as bookkeeping. And this is where the horror shifts. Because now the question isn't what happens to you, it's what does existence even mean under these conditions? You assume space is fundamental, that objects occupy locations, but modern physics increasingly treats space as emergent, something that appears when information organizes in specific ways. If that's true, then black holes aren't just extreme objects. They are stress tests for reality itself. They tell us whether space is real or just a convenient illusion that works until it doesn't. And black holes are exactly where it doesn't. Now add one more destabilizing fact. Black holes don't sit quietly. They merge. When they do, space-time doesn't ripple gently. It convulses. Gravitational waves carry away energy, angular momentum, information about the collision. These waves are measured with instruments sensitive enough to detect distortions, smaller than atomic nuclei. And what do those measurements say? They match predictions from relativity with absurd precision. Up to the horizon. Beyond that, silence. The math works perfectly until it doesn't, which means the breakdown is real, not experimental. Nature is letting us see the edge of coherence, and you are falling straight toward it. You might still be clinging to one comforting thought, at least the universe is deterministic. At least what happens next is fixed. Even that may be wrong. Quantum effects near horizons suggest space-time itself fluctuates. The horizon isn't a clean boundary, it shimmers, which means the idea of a sharply defined inside and outside may be another lie intuition tells you to stay sane. There may be no single moment you cross, no clean event, just a gradual loss of classical meaning. And here's the part nobody likes to hear. If space-time is emergent, if information is primary, and if horizons scramble that information beyond recognition, then you are not falling into a place. You are being transformed into correlations the universe redistributes, not destroyed, not preserved, rewritten. That's not spiritual, that's computational. The universe doesn't care about narrative continuity, it cares about conservation laws. And if those laws are satisfied, your expectations are irrelevant. Now zoom out one last time. Black holes are not rare anomalies. Every large galaxy has one. They shape stellar orbits. They regulate star formation. They influence cosmic structure, which means the most extreme breakdowns of space-time are not fringe cases. They are central features of the universe. Reality is built around objects that expose the limits of understanding. And that should reframe what knowing means. You don't understand the universe by making it intuitive. You understand it by discovering exactly where intuition dies. Black holes are not terrifying because they kill you. They are terrifying because they expose how thin your mental scaffolding really is. They show you that space, time, causality, and identity are conditional conveniences. They work until the universe decides they don't. And the universe does not warn you when that moment arrives. It just keeps going. We're almost done. There's one final reframing left, the one that turns all of this back on you, not emotionally, structurally. At this point, you might be waiting for resolution, a final answer, a clean conclusion, where the universe snaps back into something understandable. That instinct is the last thing black holes dismantle. Because the final truth isn't hidden at the center, it's embedded in how badly you want closure. You assume understanding means completion, that if you follow the logic far enough, the universe will eventually explain itself in human terms. That assumption works for engines. It works for chemistry. It works for weather models. It does not work at cosmic scale. Black holes don't represent missing knowledge. They represent the edge conditions of knowledge itself. They show you where explanation stops being a story and becomes a boundary. And that boundary isn't emotional, it's structural. You were never meant to experience a black hole and report back. Not because it's dangerous, because it's incompatible with communication. The universe allows regions where cause and effect no longer loop back, where reality continues without witness. That's the quiet, terrifying correction. Now turn the lens back on yourself. You think you live in a stable universe because your environment is forgiving. Earth gives you weak gravity, slow time distortions, space that behaves politely, so your intuition gets lazy. You start believing the universe is fundamentally reasonable. Black holes prove it isn't. They prove that your daily experience is a narrow slice of conditions where broken ideas happen to work. Not because they're true, because the errors are small enough to ignore. And once you accept that, something subtle shifts. You stop asking, "What happens to me if I fall in?" That question assumes you are the central variable. Physics doesn't agree. The more honest question is, what does the universe permit to exist at all? And black holes answer with brutal efficiency. They permit regions where time has direction but no return, where space exists without extension, where information is conserved in ways that destroy identity. They permit contradictions to coexist until measurement demands reconciliation. And they permit you, briefly, to think you understand them. That's the final myth, that black holes are exotic objects you can eventually tame with better metaphors. They aren't. They are consistency tests for reality. Every serious theory of the universe must pass through them and survive. Most don't. So when you imagine falling into a black hole, stop picturing destruction, picture continuity without comprehension. Picture physics working flawlessly, right up until the moment it refuses to translate itself for you. The universe doesn't become hostile. It becomes indifferent to your categories. And that's the humbling part. Not that you are small, not that you can die, but that the universe is vast enough to include regions where meaning itself doesn't propagate. You don't disappear in a flash of violence. You disappear in a way that leaves the rest of reality perfectly intact. No screen, no signal, no closure, just equations doing what they do until even they stop pretending to know. That is the terrifying truth. That all is a set of red. Something rich is always a set of cause which will be asked to it.